The battleship did not return in triumph. It came back wounded, moving slowly across the darkened Pacific, its hull torn open by steel and fire. Smoke still clung to its superstructure. Several of its great guns, once symbols of certainty and power, stood silent, locked in place by shock and damage. Every vibration of the engines carried uncertainty through the steel beneath the sailors' boots. Below the waterline, the ocean forced its way inside. Men watched helplessly as seawater spilled through ruptured compartments, rising inch by inch, turning passageways into flooding corridors. Pumps labored without rest, but the ship continued to list, leaning under the quiet, relentless pressure of gravity. In those moments, survival was measured not in strategy or doctrine, but in minutes and bulkheads. Across the Pacific, the scene repeated itself. Japanese attacks had struck with precision and confidence, leaving multiple American ships damaged or disabled in a single night. Battleships were holed, cruisers burned. Entire formations that once projected dominance now struggled simply to remain afloat. To outside observers and to enemy planners, it appeared decisive. Fleets did not recover from this kind of damage quickly. They disappeared for months, sometimes forever. Naval Command understood the arithmetic of war. A battleship sent back to a distant shipyard meant weeks of towing, months of repair, and the near certainty that it would not return in time to shape the next engagement. Admirals felt the weight of delay as heavily as any loss. Crews felt it too, not only in exhaustion, but in doubt. A damaged ship was more than steel and machinery. It was morale made vulnerable. From the Japanese perspective, the conclusion seemed obvious. The American fleet had been struck at its core. Momentum favored the attacker. Each crippled hull represented space gained, time bought, and confidence reinforced. Victory no longer felt abstract. It felt imminent. Then something unexpected appeared on the horizon. Not a warship, not a tug, but a vast, silent structure moving with purpose. A floating repair facility drew alongside the damaged battleship, its cranes already swinging into position, engineers stepping aboard as if the battle had never ended. And in that moment, the assumptions of the war quietly began to fracture. To those watching from a distance, the pattern made no sense. A ship reported crippled one evening appeared again days or sometimes hours later, moving under its own power, guns recrewed, and signals active. Vessels that should have vanished into repair yards instead seemed to pass briefly into absence, only to return unchanged. It was as if the fleet itself had learned how to disappear. Japanese reconnaissance officers struggled to reconcile their reports. Damage assessments no longer aligned with reality. Hull breaches that should have required dry dock reconstruction were no longer decisive. Air crews noted familiar silhouettes reappearing in formation. Intelligence summaries were rewritten, then rewritten again, each revision more uncertain than the last. The problem was no longer American firepower. It was American recovery. Among U.S. sailors, the explanation took on a quieter tone. They spoke of immense floating dry docks that moved without ceremony, appearing alongside wounded ships like silent giants. Steel frameworks rose and sank with deliberate calm. Cranes swung overhead with measured confidence. There was no spectacle, only efficiency. The sea itself seemed to cooperate, holding ships steady while men worked against time. Salvage and repair crews operated with a discipline that bordered on the mechanical. Welders sealed ruptured hulls while pumps forced back the ocean. Armor plates were cut, fitted, and secured with practice speed. Electrical systems were restored in parallel with structural repairs, each team working without pause, each task synchronized. Damage that once meant surrender now became a problem to be solved. The result was unsettling. Ships thought damaged beyond use rejoined the fleet before enemy planners could react. Operational gaps closed almost as soon as they opened. Commanders began to recognize something unprecedented. Repair itself had become a form of combat power, not defensive, but actively disruptive. Enemy field reports struggled to describe what they were witnessing. The phrase that spread through briefings was simple, almost superstitious. They called them ghost ships, not because they were unseen, but because they refused to stay broken. The miracle was not the steel. It was the people who refused to let it fail. Engineers and sailors worked side by side in spaces never meant for repair, let alone speed. Ranks softened under necessity. A machinist listened to a boatswain. An officer handed tools instead of orders. Under constant pressure, collaboration became instinct rather than instruction. Workshops emerged wherever there was room to stand. Passageways became fabrication lines. Mess decks turned into planning tables littered with blueprints and chalk markings. Damage that defied textbook solutions demanded improvisation. Cracked frames were reinforced with cut steel scavenged from non-essential sections. Systems designed for peacetime were reimagined in hours. Nothing was elegant. Everything was urgent. Welders struck arcs through darkness while the ship still smelled of smoke and oil. Machinists measured by feel when instruments failed. Repairs continued through tropical storms that rattled hulls and blurred the line between sea and sky. Sometimes enemy aircraft were still reported nearby. Sometimes explosions echoed beyond the horizon. Work never stopped. Fatigue was acknowledged, then ignored. Men who had been injured days earlier returned to duty sooner than expected. Burns were wrapped, fractures braced. Exhaustion accepted as a cost rather than an obstacle. These were not acts of recklessness, but of calculation. Every hour mattered. Every skilled hand restored to the effort shortened the ship's absence from the fight. Each completed repair became a quiet demonstration of coordination. Pumps, welds, electrical systems, and structural fixes aligned not by chance, but by shared understanding. Speed did not replace skill, it revealed it. What looked impossible from a distance resolved into a sequence of disciplined decisions, executed without pause. To Japanese observers, the outcome was baffling. They could measure steel thickness and blast radius. They could estimate damage. What they could not quantify was resolve the human refusal to accept delay as destiny. The machinery made recovery possible. The people made it inevitable. And slowly, almost unnoticed, the balance shifted. Survival no longer depended solely on armor or guns, but on the minds and hands that could restore. In Tokyo, and at forward headquarters across the Pacific, the early calculations appeared sound. Imperial planners understood naval arithmetic as it had always existed. A damaged battleship was not merely slowed, it was removed. Hull breaches meant towing, fires meant stripped interiors. Major repairs meant dry docks thousands of miles away. Time, they believed, would finish what bombs and torpedoes had begun. Ships that had run aground or settled into shallow harbors were written off with quiet certainty. A vessel resting on the seabed, even if partially intact, was no longer considered a fighting asset. History supported that judgment. Fleets did not resurrect themselves quickly. They withered while replacements were built. The Pacific, vast and unforgiving, magnified every delay. With each successful strike, confidence deepened. Japanese after-action reports listed damaged American ships as neutralized for the foreseeable future. The balance sheet of the war appeared to tilt steadily in their favor. Losses could be absorbed if the enemy remained unable to respond at scale. Initiative, once seized, could be held if the opponent remained trapped by repair timelines. Scattered intelligence hinted at recovery efforts, but these were largely dismissed. Observations of activity around damaged hulls were categorized as cosmetic pumping water, clearing debris, raising morale, temporary measures, nothing more. Strategists assumed such efforts could not restore combat readiness in any meaningful time frame. The fundamentals of naval engineering, they believed, were immutable. What went unrecognized was the depth of American industrial adaptability. The Japanese war plan accounted for factories, shipyards, and production rates, but not for mobility. Repair was imagined as static, bound to shore and schedule. The idea that industrial processes themselves could move with the fleet did not fit existing doctrine. This confidence was reinforced by belief. Japanese naval leadership placed profound trust in technological refinement and strategic foresight. Their weapons were precise, their planning meticulous, their understanding of naval warfare deeply rooted in decisive engagements rather than prolonged attrition. In such a framework, recovery speed was secondary. Destruction remained the primary measure of success. And so the assumption hardened into certainty. The American fleet, damaged and dispersed, would require time, more time than the war would allow. Victory, while not yet complete, felt inevitable. What planners did not see were the quiet preparations unfolding beyond their calculations. Because behind the visible damage, beyond the reach of reconnaissance photographs and intercepted reports, a different kind of weapon was already being assembled, one that would not fire a single shot but would soon begin erasing every advantage they believed they held. American naval confidence took a different shape. It was not loud nor careless, but it was unmistakable. Navy leaders had long trusted the fundamentals of their ship: design compartmentalization, redundancy, and modular construction, intended to absorb punishment rather than collapse beneath it. Damage, in this view, was not defeat. It was a condition to be managed. That belief extended beyond the ships themselves. Floating dry docks, repair tenders, and mobile workshops had existed before the war, but never at this scale, never this close to active combat. On paper, the concept was sound. In practice, it was untested. No Navy had attempted to make large-scale repairs part of frontline operations. Yet, within that uncertainty lay promise if the system could work under fire. Engineers were given little time to debate theory. Wartime pressure compressed decision-making to its essentials. Procedures were simplified. Redundancies were removed. Speed became a metric equal to strength. Designs were adjusted not for perfection, but for immediacy. Every hour saved in repair was an hour returned to combat readiness. This confidence evolved into something sharper, controlled audacity. Repairs were ordered in forward areas still within reach of enemy aircraft and submarines. Ships were patched where they lay, rather than towed to safety. Floating dry docks maneuvered into exposed waters, their silhouettes large and unmistakable. It was a calculated risk, one that acknowledged danger rather than denying it. Not everyone agreed. Skeptics within the Navy warned that these floating structures were irresistible targets, slow, vulnerable, and impossible to conceal. A single successful strike could cripple not just a dock, but the repair capacity of an entire task force. The fear was not irrational. It was strategic. Yet delaying repairs carried its own cost. Commanders weighed the alternatives and made their choice. They would rely on people as much as protection, on dispersion rather than concentration, on skill, speed, and adaptability to offset exposure. The gamble was not that the system was invulnerable, but that it could function faster than the enemy could react. Gradually, evidence replaced speculation. Ships returned sooner than expected. Repairs held under stress. Enemy attacks missed their window. What had seemed reckless began to look precise. Expectations on both sides of the conflict started to fracture, because what began as a risk was revealing itself as an advantage. And with every successful repair completed under hostile conditions, the balance shifted further. From a distance, the repair ships looked deceptively simple, hulking platforms of steel and scaffolding drifting behind the fleet. In reality, each one was a self-contained industrial city. Workshops were stacked within their hulls, equipped with lathes, presses, and cutting tools. Cranes towered overhead, capable of lifting turrets, engines, and armor plate with careful precision. Power generation, fuel storage, and pumping systems operated continuously, turning seawater and raw material into restored combat power. Nothing about their operation was static. Engineers worked in constant communication with combat units, adjusting repair priorities as the tactical situation shifted. A ship scheduled for extensive hull work might suddenly be needed within hours. Plans were redrawn in real time. Crews adapted without ceremony, breaking down complex repairs into what could be accomplished before the next engagement. Time was the governing constraint, not ideal conditions. Behind every successful repair lay an invisible supply chain. Steel plate, welding rod, electrical cable, replacement valves, all had to cross thousands of miles of ocean. Cargo ships timed their arrivals to narrow windows of opportunity. A single missing component could stall an entire operation. Efficiency was not a preference, it was survival. The margin for error was unforgiving. A miscalculated lift could collapse a crane. A mistimed pump could flood a compartment beyond control. Electrical failures risked fire in confined spaces. These were not abstract risks. They were daily calculations, managed under pressure, often at night, often while the sea refused to stay calm. Nature and the enemy conspired equally against the effort. Tropical storms disrupted positioning. Swells strained moorings. Japanese reconnaissance aircraft searched for signs of vulnerability. Daylight was limited, darkness dangerous. Yet the work continued, paced by discipline rather than optimism. Despite these obstacles, the system functioned remarkably so. Repairs that would have taken weeks in a shore-based yard were completed in days, sometimes hours. Speed was not achieved through shortcuts, but through integration. Every element: engineering, supply, command, moved, and alignment. Gradually, the implication became clear. These vessels were no longer support units in the traditional sense. They were force multipliers. By restoring ships faster than the enemy could remove them, the repair fleet began to shape the battlefield itself. What had started as logistics was becoming strategy, and the so-called ghost ships were no longer just keeping the fleet alive. They were actively taking something away from the enemy: time, certainty, and control. The true test came without warning, carried back to the fleet on a crippled hull. A battleship emerged from heavy engagement, bearing the unmistakable signs of near-fatal damage. Its bow had absorbed repeated impacts, steel plates bent inward like torn paper. One main turret was frozen mid-rotation, its machinery seized by shock. Fires had been contained, but the ship moved slowly, wounded and uncertain, escorted by vessels that did not know whether it could be saved. There was no pause for debate. Engineers boarded almost before the lines were secured. Damage control reports were read aloud while measurements were still being taken. Within hours, a floating dry dock was maneuvered into position, its massive structure settling into the water with deliberate calm. This was not a controlled exercise. It was the first time the system would be forced to prove itself against the full weight of reality. Assessment gave way immediately to action. Pumps engaged, forcing water from compromised compartments. Welders moved into place even as the hull continued to cool from battle. Mechanical teams dismantled damaged systems without waiting for ideal conditions. Every task was governed by time, not the time needed for perfection, but the time available before the ship would be required again. Sailors who had never held a cutting torch were trained where they stood. Instructions were brief, precise, and repeated only once. They learned by doing, passing tools, clearing debris, reinforcing temporary supports. The distinction between crew and repairman dissolved. What mattered was competence, not role. What mattered was speed. Temporary fixes came first. Steel plates were secured to hold the hull's shape. Cracked joints were reinforced to prevent further stress. These measures were not meant to last, but to buy hours. Behind them, permanent repairs were already underway. Components were replaced in sequence. Systems were restored in parallel. The ship was not repaired piece by piece. It was rebuilt in layers, each one enabling the next. By nightfall, the dock was still alive with light and movement. Welding arcs cut through darkness. Cranes lifted damaged assemblies clear and lowered replacements into place. Engineers recalculated timelines as progress outpaced estimates. The ship's list corrected gradually. Its silhouette steadied. Observers, both friendly and hostile, took notice. Japanese reconnaissance reports struggled to reconcile the scene. A vessel assessed as crippled was now upright, active, and visibly restored. Intelligence officers questioned earlier conclusions. Damage assessments were revised, then revised again. The recovery did not align with any known precedent. By morning, the battleship was no longer a patient. Its systems tested green. Turrets rotated freely. Engines responded without hesitation. The crew resumed stations not with celebration, but with focus. Orders came through calmly. The ship rejoined formation as if nothing extraordinary had occurred. For American planners, the result confirmed a theory. For Japanese observers, it introduced a problem they could not yet define. Speed was not achieved through haste alone. It was engineered long before the first battle damage was assessed. Prefabricated armor plates waited in standardized dimensions, ready to be cut and fitted without redesign. Gun mounts were built to be removed and replaced as units rather than repaired in place. What once required disassembly over weeks could now be accomplished through substitution in hours. Damage no longer halted momentum, it triggered a process. Portable cranes became quiet enablers of this transformation. Mounted on repair ships and dry docks, they lifted turrets, engines, and heavy assemblies with a precision once reserved for permanent shipyards. Their mobility allowed work to proceed wherever the ship lay, eliminating the need for relocation. Weight, which had once dictated delay, was no longer decisive. Steel moved when it was needed to move. Yet not all damage followed plans or specifications. Battle had a way of bending metal into shapes no manual anticipated. Here, innovation emerged not from blueprints, but from judgment. Engineers fabricated solutions on the spot, custom braces, improvised fittings, rerouted systems, each designed to solve a problem that had not existed the day before. These were not acts of inspiration in isolation, but the product of shared experience and relentless pressure. The work unfolded with an efficiency that felt almost deliberate. Welding teams, pump operators, and electricians moved in sequence, each task timed to enable the next. Flooded compartments were drained as power was restored. Structural reinforcement followed system repair, not the reverse. The process resembled choreography more than labor, every movement purposeful, every pause calculated. Even the floating dry docks themselves became part of the tactical equation. They were repositioned constantly, adjusting orientation to weather, light, and threat. Protective screens were established when possible. Repairs were paused, accelerated, or concealed based on reconnaissance reports. The dock was no longer a passive platform. It was a maneuvering asset, treated with the same care as any combat vessel. With each successful operation, morale shifted. Crews saw proof that speed could blunt the force of destruction. A hit no longer meant absence. Damage no longer implied defeat. Confidence grew not in invulnerability, but in response. The knowledge that a ship could return quickly changed how sailors fought and how commanders planned. For the enemy, the effect was subtler but profound. Attacks that should have reduced strength now produced uncertainty. The visible results of firepower were being erased before conclusions could be drawn. The battlefield refused to remain static. Innovation, once considered support, had crossed a threshold. It was shaping outcomes. It was shortening the enemy's advantage window. And with each repaired hull and restored gun, it became clear that technology, applied with speed and intent, could unsettle even the most carefully calculated destruction. What had begun as a method was now a message, and it was being delivered faster than the enemy could understand. The pace did not ease when the machinery was in place. Sailors and engineers worked through cycles that ignored the clock, dividing time not into shifts but into tasks that had to be finished before the next order arrived. In tropical heat, sweat pooled on steel decks already warm from welding arcs. In heavy rain, tools slipped and visibility vanished. Yet the work continued. Night and day blurred into a single, extended effort. Injuries were acknowledged with efficiency rather than ceremony. Burns were treated, cuts bandaged, exhaustion managed just enough to continue. Fear existed, but it was rarely discussed. Enemy aircraft might return. Submarines might be nearby. Storms could turn suddenly. None of it altered the immediate problem. A ship that had to be saved before time ran out. Shared purpose reduced individual doubt to something manageable. Leadership adjusted to the reality. Orders moved horizontally as often as they moved down the chain of command. Decisions were made where the problem was visible, not where rank resided. An engineer could halt a procedure. A petty officer could propose an alternative. Authority was defined by understanding rather than insignia. Speed demanded trust, and trust reshaped hierarchy. The results were tangible. Repair crews kept ships afloat that would otherwise have been written off. Hulls stabilized hours before they would have flooded beyond recovery. Engines were coaxed back to life just long enough to reach safety, then strengthened to return to combat. Each saved vessel represented not only material preservation, but time reclaimed from the enemy. Stories began to circulate quietly through the fleet, of welders who sealed ruptures while compartments filled around them, of machinists who improvised parts from scrap when replacements failed to arrive, of sailors who learned new skills mid-crisis and applied them without hesitation. These accounts were not publicized. They were passed in mess lines and engine rooms, reinforcing a shared belief that problems could be solved. That belief began to influence strategy. Commanders planned operations with an understanding that damage no longer meant prolonged absence. The fleet could absorb impact and remain present. Morale shifted accordingly. Confidence did not come from invulnerability, but from resilience, the assurance that setbacks could be answered faster than they could accumulate. Gradually, the damaged ships themselves took on new meaning. Repaired hulls carried visible scars, patches, seams, altered lines that told their own story. They returned to formation not as restored originals, but as proof of refusal. Each one was a statement that destruction had limits. The so-called ghost ships had done more than preserve metal. They had transformed broken vessels into symbols, not of survival alone, but of defiance, a message carried quietly across the Pacific, visible to friend and foe alike, and impossible to ignore as the war moved toward its next turning point. At first, the reports were treated as anomalies, Japanese reconnaissance aircraft photographed American ships returning to operational areas sooner than expected, sometimes impossibly soon. Hull numbers matched earlier damage assessments. Silhouettes were unmistakable, yet the timelines were wrong. Vessels recorded as crippled were moving with purpose, maintaining formation, signaling readiness. The gap between expectation and observation began to widen. Intelligence officers struggled to reconcile the contradiction. Battle damage had been carefully documented. Torpedo strikes, bomb hits, fires, these were not superficial wounds. According to established doctrine, such ships required extensive yard work, often far from the front. And yet, there they were, operational, armed, present. The question was no longer whether the reports were accurate, but how the outcome had been achieved. As uncertainty spread, language shifted. The phrase "ghost ships" began to appear in internal communications, first informally, then with growing frequency. It was not meant literally. It was an expression of frustration, a way to describe vessels that refused to behave as expected. Ships that should have vanished instead reappeared, unchanged by logic or precedent. The name carried unease with it. This unease forced recalculation. Naval planners had relied on attrition models that assumed removal was permanent, or at least prolonged. Now, every assessment came with a caveat. A ship marked as sunk or disabled might return. A successful strike might buy hours rather than weeks. The certainty that underpinned earlier confidence began to erode. Among Japanese sailors, the effect was personal. Crews who believed they had fought effectively now faced familiar adversaries again. Victories felt incomplete. Repeated encounters with the same hulls blurred the psychological boundary between success and futility. Confidence, once reinforced by visible results, began to thin under repetition. Commanders, too, felt the shift. Strategic dominance of the Pacific depended on space and time on the enemy's inability to respond quickly. If damaged fleets could regenerate near the front, the equation changed. Control of the battle space became harder to sustain. Initiative could no longer be assumed to carry forward unchallenged. Questions emerged that had not been asked before. Could the Pacific truly be dominated if the opponent refused to stay weakened? Could destruction alone secure advantage if recovery moved faster than removal? The answers were unclear, and that uncertainty was itself destabilizing. What had begun as a logistical curiosity had grown into something more consequential. Repair was no longer invisible. It was influencing morale, planning, and perception. The battlefield extended beyond guns and torpedoes into workshops and supply lines. And in that realization lay the first true psychological turning point of the war, an understanding, slow and unwelcome, that the enemy had found a way to fight back without firing, and that every future engagement would now be contested not just by force, but the shift revealed itself first in tempo. Fleet operations no longer paused to absorb damage. Ships returned to the line not after deliberation, but by design. A vessel struck one day could be counted again within the next operational cycle. Schedules tightened. Task forces moved with a confidence rooted not in optimism, but in expectation. Damage had become a variable, not a stopping point. Floating dry docks followed the fleet's movement, repositioned along supply routes with deliberate intent. What had worked once was replicated again and again, across islands and anchorages, across thousands of miles of ocean. Repair capacity was no longer centralized. It traveled. Wherever ships fought, recovery followed. The Pacific, once an obstacle to logistics, became a corridor for it. Engineers refined their craft relentlessly. Each repair offered data. Each delay became a lesson. Procedures were shortened, tools modified, sequences reordered. Hours were shaved away through repetition and adjustment. What had taken a night now took an evening. What had taken an evening now took less. Speed was not accidental, it was accumulated. Naval planners took notice. Repair time was no longer a background assumption. It became a planning factor. Operations were designed with recovery windows in mind. Risks, once deemed unacceptable, were reconsidered. Commanders understood that a damaged ship was not necessarily absent from the next phase. The fleet's endurance expanded without adding hulls. Enemy attacks increasingly failed to achieve lasting effect. Strikes that should have reduced strength produced only momentary disruption. The enemy's calculus built on delay and depletion no longer held. Firepower still mattered, but its consequences were shortened. The advantage gained through destruction evaporated faster than it could be exploited. This created opportunity. American forces could press forward where others might have withdrawn. Adversity became a test rather than a deterrent. Each engagement fed the system that supported the next. Momentum, once fragile, became self-sustaining. Crucially, this mastery remained largely invisible. Repair ships did not appear in headlines or communiques. They did not engage the enemy directly, yet their effect was measurable everywhere else in ship counts, in readiness reports, in the enemy's growing uncertainty. They shaped outcomes without being seen. By this stage of the war, the question was no longer whether repair ships mattered. It was how long the enemy could continue to fight as if they did not. The fleet was not merely surviving, it was learning, adapting, accelerating. What had once been an experiment had hardened into doctrine. Repair was no longer reactive. It was integrated. It was expected. It was decisive. And as operations surged forward with a rhythm the enemy could not match, it became clear that the most powerful force in the Pacific was not always the one delivering the blow, but the one that ensured the blow never lasted. By this stage of the war, the rhythm of operations had fundamentally changed. Battleships, cruisers, and carriers no longer moved through a linear cycle of combat, withdrawal, and distant repair. Instead, they rotated through a continuous loop: engage, recover, return. Damage no longer removed ships from the equation. It merely redirected them briefly. The fleet had become elastic, absorbing shock and regaining shape with remarkable speed. For Japanese commanders, the effect was disorienting. Ships recorded as sunk or disabled reappeared within days, sometimes before new plans could be finalized. Familiar hulls returned to contested waters, bearing fresh scars, but also renewed capability. The assumption that time favored the attacker began to collapse. Each engagement no longer promised lasting advantage. Some promised none at all. American fleet commanders learned to exploit this reality. Repair speed became an instrument of surprise. Ships thought absent were held back deliberately, then reintroduced at decisive moments. Campaigns were sustained beyond what enemy planners believed possible. Pressure could be applied continuously, not because losses were avoided, but because losses were recovered faster than expected. Behind this endurance stood industrial capacity, vast, coordinated, and largely invisible to those facing it. Shipyards, supply depots, training facilities, and repair ships formed a single extended system. Production did not end at launch. Engineering followed the fleet forward. What the enemy encountered was not just a navy, but an industrial process in motion. Logistics, once considered secondary to firepower, proved inseparable from it. Engineering turned raw material into restored strength. Morale followed function. Crews fought differently when they believed their ships could be saved. When damage did not mean abandonment, the system worked, but it demanded payment. Behind every rapid repair stood crews pushed to the edge of endurance. Engineers and sailors carried injuries that rarely appeared in official tallies. Burns from molten steel, crushed fingers, lungs irritated by smoke and fumes. Sleep came in fragments, taken where it could be found. Exhaustion accumulated quietly, accepted as part of the price of keeping ships alive. Each success carried risk. Men worked in flooded compartments where a failed pump could mean drowning in minutes. Welding was performed near fuel lines and ammunition stores, where a single mistake could ignite catastrophe. Fires were an ever-present threat, flaring without warning in confined spaces already damaged by battle. The work demanded precision under conditions that punished even small errors. Far from the forward areas, families waited. Letters arrived late or not at all. News spoke of battles and movements, but not of the labor that followed them. Few at home knew that ships thought lost had been saved through nights of unseen effort, or that the men performing that work faced dangers no less real than those on the firing line. The labor remained largely invisible. Its impact felt but rarely explained. Losses continued. Ships were still sunk. Men were still killed. Repair did not erase the cost of war, it narrowed its margins. Ingenuity mitigated damage, but it could not eliminate it. Every restored vessel represented not only success, but the acknowledgement that something had first been broken, often at terrible human expense. Over time, accounts began to surface in reports and memoirs, quiet descriptions of impossible-seeming repairs, of men who stayed at their stations as water rose around them, of teams who held fractured hulls together long enough for reinforcements to arrive. These stories were not framed as heroics. They were recorded as facts, almost reluctantly, as if the scale of the effort resisted embellishment. The ghost ships themselves came to symbolize this dual reality. They were marvels of engineering and coordination, but also reminders of the strain required to sustain them. Their success depended on people willing to accept danger repeatedly, without assurance of recognition or rest. Innovation carried weight, and that weight was borne by human bodies. Yet the psychological effect of endurance was profound. Crews who had seen their ships survive damage once believed they could survive it again. Fear did not vanish, but it was reshaped. The impossible had been endured, and that knowledge lingered. Confidence grew not from invincibility, but from experience. Across the fleet, this quiet victory resonated. Ships returned bearing scars, crews returned bearing fatigue, but they returned. And in a war defined by attrition, that fact alone carried meaning. The ability to survive, to repair, and to fight on became its own form of triumph, one paid for in effort, sacrifice, and resolve that rarely appeared in headlines, but altered the course of the war all the same. By the later stages of the war, what had once been an improvisation hardened into doctrine. Floating dry docks and modular repair units were no longer experimental solutions applied under duress. They became expected components of naval planning. Fleets were designed with repair in mind, not as an afterthought, but as an integral function. Damage was anticipated, not feared, because recovery had been engineered into the system. Speed and flexibility reshaped priorities across naval engineering. Designs emphasized access, interchangeability, and rapid replacement over perfection. Systems were simplified where possible, standardized where necessary. The goal was not merely to build ships that could fight, but ships that could be restored quickly when fighting took its toll. Engineering shifted from static endurance to dynamic resilience. These lessons did not remain confined to wartime improvisation. Shipyards at home studied the methods developed at sea and began adapting them for peacetime use. Mobile repair concepts influenced harbor design, logistics planning, and industrial workflows. The boundary between frontline maintenance and rear area production blurred. Industry learned to move, not just to produce. Enemy planners, however, never fully integrated this reality into their calculations. Intelligence recognized the phenomenon but struggled to translate it into counter-strategy. Logistics remained secondary in their assessments, subordinate to decisive engagement and firepower. The idea that recovery itself could dominate outcomes remained underestimated, even as evidence mounted. As warfare evolved, repair speed increasingly shaped success. Future battles would not be decided solely by who struck first or hardest, but by who could recover fastest. Attrition favored adaptability. The capacity to absorb damage and return became as valuable as armor thickness or gun caliber. Repair emerged as a strategic constant rather than a temporary advantage. Innovation proved its equal standing with weaponry. It did not replace force, but it redefined its limits. Firepower could destroy, but innovation could deny that destruction permanence. In doing so, it altered the meaning of loss and the pace of conflict. War became not only a contest of strength, but of systems. The ghost ships left a legacy that was easy to overlook and impossible to ignore. They demonstrated that unseen power could shape visible outcomes, that logistics could bend strategy, and that damage could be transformed into opportunity. Steel still mattered. Courage still mattered. But the war had revealed something quieter and just as decisive. In the end, these vessels did more than repair ships. They repaired assumptions about time, about vulnerability, about what truly determines victory at sea. And long after the guns fell silent, the lessons they carried forward continued to shape how nations prepared for the wars they hoped never to fight again. In the end, the so-called ghost ships offered a lesson that is often overlooked. Outcomes are shaped not only by equipment or scale, but by the ability to adapt, rebuild, and sustain complex systems over time. Innovation may challenge existing strengths, but long-term effectiveness depends on whether adaptation can be maintained. Across American industry and engineering, temporary setbacks were transformed into renewed operational readiness with quiet efficiency. What initially appeared to be lasting limitation was repeatedly converted into continued presence. Progress did not announce itself, it simply continued, steadily and consistently. In this process, traditional boundaries softened. Individuals, working far from visible events, influenced results as decisively as those closer to them. Effort extended beyond isolated moments into supporting spaces, engine rooms, temporary workshops, and recovery facilities at sea. The Pacific region was shaped not only by moments of intensity, but by endurance, by the capacity to return, to persist, and to remove the expectation that interruption would remain permanent. Restoration became continuity. Continuity became advantage. And advantage, over time, became success. Standards evolved accordingly. Speed and adaptability joined discipline and coordination as defining strengths. Innovation moved from the margins to the center. Progress was no longer measured only by moments of change, but by the speed at which stability was restored. From another viewpoint, the effect was gradual but unmistakable. Assumptions weakened. Early confidence lost permanence. Strain accumulated not from a single event, but from encountering a system whose setbacks refused to accumulate. And so the legacy of the ghost ships endures not in monuments, but in understanding. They demonstrated that modern outcomes depend as much on sustaining capability as initiating action. Progress belongs not only to those who moved first, but to those who could restore function before interruption could define the result.